can be modeled mathematically. The difficulty we run into in trying to deal with such a figure. What figure can you wrap around this object and it will be perfect and best fit? No matter the figure you use, some places will be affected and some places will be closer to reality. So the idea for what we call the geoid and the ellipsoid is basically the best, having compared so many models to the nature and shape of the earth. So this one is when we talk of the globe, so smooth and nice. But then after this, we begin to appreciate the real earth minus the ocean, of course. But even if you take the ocean issues away and concentrate on the land masses, say South America, you see the bulging that is happening here, the lows and high of North America. So we have Australia down here. Then you have Russia and the Middle East, and this now Africa. I want you to look at Africa again closely. Good. Even in this model, this side like this, for instance, is in the low part, it's on the high ground. But the whole of this is the Africa continent as we have it. But look at the shape of the whole world as one side. Look at the edges here. It bulges in, comes out, goes this way. When it gets here, it drops sharply, it goes up, it drops, goes up, it goes down. And as it turns or rotates, you can appreciate the difficulty in trying to fit different models to it. So really, it's a kind of weird object, yet we have to find a way of modeling it. So what we call the ellipsoid, like I said earlier, is the best model mathematically using the ellipse to fit onto the earth. But it doesn't satisfy everybody's needs. That is why later on, when we talk of datum, you understand different countries adopt different strategy for datum. Because somebody is in the valley, as you just saw, somebody is on the hill. So the model will be good. See, when you take an ellipse, it will be flying over these people. It is your model. You see that when you go here, you'll be going this way to connect. These people here, you'll miss it. In some cases, you'll be cutting some of the earth body away by the model definition. And so those are the difficulties that surveyors and geomaticians and geodesists, those who want to accurately measure and dealing with such a shape of the earth. It's not an easy story to tell at all. It's not an easy story to tell. So this is how our earth looks like when you take away the water body, especially the ocean. Then we have this manifestation to handle. All right, so now we've seen how difficult our model is. And it is why we said the earth as an object is not a developable object. You cannot get one piece model to go around it smoothly without distortion. But the cone and the cylinder and the plane, which we use for map projection, they are developable because when you cut them and lay them flat, there will be no distortions. They will fit the flat surface. And all the mathematical models we apply to the code will apply to the surface of the paper when made flat as well. Good. So that is the story so far with respect to our Earth coordinate system and map projection. Those information too, like I have done for what I've sent, the compilation will be brought to us through our refs. And you can then add up all the issues for our total information as far as the presentation lecture is concerned. Note, however, that for the things that I spoke to you to make notes or assignment or research into, they are not in the material nor in the presentation. At least as far as my mind can calculate. If some are there, then that is not bad. But majority of them may not be there. So if I did ask you to do some 1 or 2 fillings, make sure you have done that. They are still part of the discussion. All right. So can I proceed?
Yes, Doc.
Good. Thank you very much. So I think in the last thing we ended, was it with map projection? My second assignment, or one of the other assignments I asked you to do, I hope you have done it too. I told you to look at the spheroid for Togo. Have you done that? I told you to read about 3 of them, WGS 84, War Office that Ghana uses, and then I said determine that which is used by Togo. Please, have you done it?
Doc, we did the first 2.
You did the first 2, why couldn't you finish up with the third? Because the same environment where you are looking for the information for the WGS 84 and then the War Office. Well, so that is the issue. Let's try and pick that one. It's very, very important. All right. So we want to continue our discussion. If I recall, let me see the presentation that I used the last time, and then now we can proceed. All right. So I think we did that. Please, there's one more thing I need to highlight. Somewhere in the discussion, when I was talking about methods of surveying, we talk about the chain, and I shared some diagram with you where we're talking about the main stations, the main survey lines, the subsidiary stations, the tie points, how we pick our details by offset. We said there were 2 of them. We have perpendicular offset and then oblique offset. On that slide and going forward, we are contemplating on how we can deal with the traverse. But I think because of time, among other things, I decided to shove off that one. But I need to also highlight, please, I've also done one when I was discussing the surveying instruments. We talk about the chain there, we talk about the EDMs, we talk about the tape, we talk about the compass, we talk about the total station, and we also talk about the GPS, Global Positioning System. Please, this one, both in your quiz that you'll be doing and in the end of term exams. Issues about the chain and issues about the GPS instrument are going to be part of our assessment, be it either for the end of semester or for the first of the quiz we'll be doing. So please, let's watch it. Let's watch it and let's get to it. So I couldn't talk about the traverse in detail, although I gave you the general and then the types, open versus close. But the GPS was the next in line. But we have discussed the GPS as an instrument, which is totally no different from how it operates and how it works. The purpose of a GPS is to determine your location, your position accurately on the surface of the earth. To be able to do that, it's a system that operates. And when we're talking about the instrument, I described the system. I mentioned control segment, I mentioned space segment, I mentioned user segment. Please, all of that is part of our material. Week 2, material 2A, the PowerPoint. Among other instruments, the GPS is there. So my discussion with you is basically to inform you that we can be asked questions on that. So we should take notes. We should take notes. All right. So quickly, let me move over and try and come to what we want to finish off with. But then there was this other bit I left out. I will plead with you so that I go and do the insertion, because every now and there are questions also that come over. In fact, in terms of the notes, it's in the notes, but we may not have done any workout up to this stage. It's an aberrance. The issue of how true bearing relates to magnetic bearing via the magnetic declination or variation. What I mean is that these three entities or three concepts or three terms are related in a mathematical formula. We have true bearing, which is the direction with respect to the true north. We have magnetic bearing, which is the direction with respect to the magnetic north, usually presented in compass. True bearing is not presented in compass because the compass uses the magnetic north and direction is reckoned to the north. So we have magnetic bearing. But it still doesn't change the fact that there's a relationship. The angular difference between the magnetic north and the true north, also known as the geographic north, is called the magnetic variation or magnetic declination. So that is what I want you to note. What then is the formula? True bearing, write it down. True bearing is equal to magnetic bearing plus or minus declination. True bearing is equal to magnetic bearing plus or minus declination.
Please, plus and minus, we didn't hear the last word.
Plus or minus. Declination. Declination is a short representation of what we call magnetic declination. The same magnetic declination is also called magnetic variation. So in the formula, we took off the magnetic and we are saying declination. Declination. Magnetic north is not the same alignment as true north. And the angular difference between these two is called magnetic declination. Magnetic declination. I will pull up the formula onto your screen very soon. And I will share that expression with you. So those of us who didn't get it right, for us to be able to pick it right. So where is my formula? Good. Here we are. If you had dealt with a traverse, we would have dealt with what we call the compass traverse. But because we took traversing out, it would have been the last part of the discussion. But I don't want to be unfair. So at times you can have questions in that domain. So now I'll share with you on the screen. Is it clear? You will see it clearly. All right. This declination can be positive or negative. That is why the sign plus or minus is here. When it is positive, usually the figure will be written with a plus prefixing the value, like plus 2 degrees Another way of qualifying the plus is to say that the declination is east. So usually when you hear that the declination is east, it means in the calculation, you consider that as positive. If you are told that the declination is west in the calculation, it is giving a negative sign. It's a conventional practice. Why it becomes plus or minus is because the magnetic bearing, or what we call the magnetic north, Good. So the magnetic bearing at times will lie to the right side of the true north. Then it will get the recognition of the east. There are times too it will align to the western part of the north. Then it will be assigned west. But the convention is anytime it is written without the east or west, but it's a positive quantity, note that it's talking about the east. If the value is written with a negative quantity, know that we are talking about the west. If the value is not written with a sign, but the value is set and the direction is added, and the direction is east, it will be reckoned positive, the value. When the direction is west, the value will be negated in the calculation. So the minus part of the calculation is talking about the west. The positive part is talking about the east. So note it. So we can always determine true bearing, for instance, if we know the magnetic bearing and then the magnetic variation or magnetic declination of the same place. If we have data about the true north and the magnetic declination, we can use change of subject to solve for the magnetic bearing. The last of that, which I want to speak of, is what we call forward bearing and back bearing. Forward bearing and back bearing. Please, my people, I hope the assignment on errors in chaining, you have done it.
Yes, Doc.
Yes, sir.
If you have done it, God bless you. If you have not done it, God bless you. But please, if you
Doc,
know you
we've
have
done.
not done it, go and do it. Thank you. So what do we understand or what do we mean by back bearing? Back bearing, forward bearing, back bearing. What do we understand by this terminology? I put first the definitions onto the screen. So let me share that with you. Then I'll do demonstrations and explain them because of the concept of bearing that we did. At times there are questions that they will write the bearing in one notation. What I mean by one notation, we've done whole circle, we've done quadrantal. Sometimes they'll give the question in whole circle and they'll tell you to find the back bearing to a given direction. At times you'll find the back bearing, but they'll tell you that we want the answer in the reduced bearing notation. So now we know how to change from back bearing, from whole circle to reduced bearing notation. That's the first one. What is then left is how we connect it with the concept of back bearing. Surveying, as we saw in traverse the last time, we move from point to point. Now, as you move from point to point, we follow a certain forward movement, and its associated direction is called forbearing or forward bearing. So let me deal with the definitions of these two, which is forbearing or forward bearing, and then back bearing. After which I will talk about how demonstratively we can move from one to the other between these two systems of forward bearing and back bearing. Now, as you are seeing with the definition, forbearing is a bearing measured in the progress of surveying. Progress of surveying. Progress means movement ahead. Movement ahead. That is the progress of surveying.
Hello.
Yes. Yes, we are listening. Okay.
I didn't hear anything. So I thought it's my network.
Okay. So what I've shared with you, I'm trying to implement an illustration with it. So I fixed a point here. There's another point here. There's a third point here. Let me call this one A. Let me call this one B. And then let me call this one C. In a traverse and for most survey, you move from point to point. You engage the point. So if I move, for instance, from A to B, sorry, my line is crooked, and then B to C, moving from A to B is called a forward bearing. Moving from B to C is called a forward bearing, because that is how I design my survey. I move from A to B and B to C. So the definition of a forward bearing is, as you are seeing there, the bearing measured in the progress of surveying in your work, how you were moving from point to point. It's also talking about direction from point to point. What then constitutes the back bearing? The back bearing is a bearing measured in opposite to the progress of surveying. That is, in backward direction of survey line. In backward direction of survey line. And it's also known as backward bearing. So watch the forbearing here and watch the word forward bearing. The two are the same. The forbearing For is an old English meaning ahead, in front. So when you are moving to something in front of you, like in the diagram, I'm moving from A to B, which is ahead of me. Then when I get to B, I'll move to C, which is ahead of me. Then in my movement, A going to B is a forward direction. B going to C is,
Nothing is showing on the screen now.
then please check your net. Oh.
Yeah, check your network. The screen is showing.
If it's still not coming, go out and join again. All right. So when you see somebody engage in a survey activity and you're able to see the design and how he or she went about the point, you can gather the sense of forward direction in the movement. So with my diagram, AB is a forward direction. But when I go A to B and I decide to return from B back to A, that is what we are calling the back bearing or the backward bearing. So under my normal practice, please, this thing, it can be confusing. I want you to listen very clearly to that. In my normal practice, I move from A to B. If I move from A to B and B to C, then movement from A to B and to C is a forward direction. For which case, AB is a forward bearing. BC is also a forward bearing. That's the first one. Because I move from A to B. If I show you a sketch, where in the sketch I was rather moving from C to B and B to A, then by my movement, I cannot say AB is a forward bearing. No. Because that was not how I was seen to be occupying or moving or engaging the point. I went from C to B, then B to A. In that case, then my direction will change. Max, you have your hand up.
Yes, please. If I may get it, using the same diagram that you've given over here with the illustration ABC. So does it mean that in this case, the backwards bearing, meaning the arrow will be going backwards, right? If I'm getting it right.
Yes, if you want to implement the arrows in the design, fine. Then the arrows will be going back. But I am explaining a concept, so I don't want to introduce the arrows now to get you confused. I am using the arrows for now to show my movement of the survey. Then I'm making a deduction for who will be called a back bearing. It's very important. You cannot talk of a back bearing unless you know of a given direction or a forward bearing. For instance, you cannot see me moving from A to B, and you want to talk about back bearing straight in the AB. If I'm going to talk about back bearing between A and B, I should have seen an earlier movement. There should be a situation depicting an earlier movement before I can talk of the back to that movement. Always the back, as the definition is studied, it takes is the opposite to the progress of survey, meaning that we should have an intended progress first before the opposite can be appreciated as back bearing. Max, is it clear?
Yes, please. Thank you.
So my point was that I moved from A to B and B to C, and it's fundamental in any survey activity. You always have to indicate how you went about the work. before we can make certain other deductions. The concept of back bearing means that there must be an indication in the question of a suggested forward bearing before we can think of its back. So, looking at the diagram, moving from A to B and B to C, if this was my survey, then A to B is a forward bearing. B to C is another forward bearing. Two different forward bearings are involved. That is what I've used the arrow to show. If for some reason, although this is the nature of the work that I did, I happen to have moved from B to A, given that I had earlier moved from A to B, then B to A is a direction. But the same B to A is a back bearing to AB. So I can only call BA back bearing when I have enough information to suggest that AB bearing has been given already. So if they give me the direction of AB, then the back bearing of AB will be BA. Because the action will mean I have to reverse. The action will mean I have to reverse. I have to reverse the direction. So if such is the case, then there should be an AB. If there was a given AB and you are talking of BA, then the BA that you are speaking of is the back bearing to AB. Who is BA? Coming this way is the BA. Let me use the double arrow now. The BA is a direction, all right. But that direction BA is also a back bearing. If AB was given earlier, then BA is the back bearing to AB. So something is clear in what I was explaining. You cannot talk of a back bearing and refer to the same line. No. The back bearing is an action reversal to an earlier direction. So if I tell you line AB, you cannot say back bearing AB. It's wrong. But if I give you line AB and you are looking at BA, then the B to A will be considered a back bearing to AB. So always when you hear of back bearing, it means you are attempting to reverse an earlier given direction. The direction has been stated already, and you want to reverse that direction. Then you are invoking the back bearing concept. So if nothing has happened, for instance, movement from B to A is BA, it's a direction, there's nothing wrong with it. Movement from A to B is also AB, it's a direction, there's nothing wrong with it. But if I want to talk of back bearing, then the situation should suggest to me there is a forward bearing for which I am going to determine its backward movement. So, for the last time, B going to C, if that is my forward bearing, then my back bearing will be what? C coming to B. But C coming to B with the back bearing, I would say is a back bearing to BC. So when you don't listen to the details, well, that's where you get confused. Moving from B to C is a direction. Moving from C to D is also another direction. I'm using the second leg. From here to there is direction. From here to here is direction. But if I consider from B to C, then my back bearing to BC, that is the considered direction, is CB. So CB is showing that I'm reversing what I earlier did, BC. How do these issues then reflect when you are dealing with the quadrantal or yes?
Hello. Sorry.
I'm listening.
Hello. So please here with the backward the backward bearing, would the sign the arrow change? The arrow will
Yes,
change.
the arrow will change. The arrow will change. But get how I explain it, the fundamentals right. So I'm using AB again. When you move from A to B, is the direction. That is the first arrow, single arrow. When you move from B to A, it's also another direction. That is the double arrow here. So these two directions are there. But then between these two directions, I want to explain back bearing. And the definition is saying that you have to move in opposite direction to what you were doing earlier in the course of your survey. That is what the definition is saying, opposite to the progress of surveying. Progress of surveying. Progress of survey. You will reverse it. That is why the opposite is here. So in this design, my survey was move from A and go to B, move from B and go to C. So AB is forward. BC is also another forward. But if I am looking at A going to B, then B coming to A is the back bearing to AB. Although B coming to A is BA, which is also another forward bearing, but it is in opposite action. So always, when you want to talk about back bearing, you must have an earlier bearing defined. Then you can find a back to that. If you've not created that definition or the question has not highlighted such, it will be difficult for you to apply back bearing straight away. But don't forget that I said, if it wasn't for the discussion called back bearing, when you move from A to B, it is direction AB. When you move from B to A, it is direction BA. The two directions are correct. But then the back comes in only when I consider my first movement of A going to B. And I'm seeing the back as my intentional reversal of A going to B. So that it now becomes B coming to A. So you have AB and you have forced it to move opposite. When you force it to move opposite, we say you have a back bearing action. That back bearing action can also be representing another person's direction. In this case, B going to A is a direction. So A going to B is a direction, B going to A is also a direction. No problem with that. But then, if I have A going to B, then the back bearing of A going to B is B coming to A. Is it clear?
Yes, sir.
Yes, Doc.
Yeah, okay.
All right. In value, how does this one work? I'm going to pull a slide so that we can do our drawings. And then that will help us to quickly understand. So we'll start with the whole circle bearing concept first. So let me get an example bearing. and then we'll find the back bearing to that. All right. So for our first model and discussion, let me talk about full circle bearing. Sorry for my bad scribbles. All right. You have a line. The line is called OJ. And we are told a bearing, which is the same as the forward bearing when they don't attach that. The bearing of the line OJ is, let's say, 120 degrees. And you want the back bearing to this line. Good. How do you find that? There is a formula for that. And this is how I write it. Back bearing, BB. Please write that one too for me. BB, back bearing, is equal to forward bearing plus or minus 180 degrees. You know, in math, when you have a line moving straight this way and you reverse it to move this straight, which is the concept of the back bearing. The difference between this top one direction and the reversal is 180. Are you aware of that? It's one of the principles in mathematics. And surveying also uses it. Please, generally, do you know that when you have two lines, they are parallel to each other, but the directions are in opposite sense? The difference in the direction is 180, or the difference in the angle is 180. If you don't know that, maybe you can note it tonight. So this is the formula. So the back bearing is equal to the forward bearing plus or minus so back bearing is equal to forward bearing plus or minus 180. When do you plus the 180 and when do you subtract the 180? When your figure you are using, the figure given, is less than 180, you will add 180 for the back bearing. But if the figure given is more than 180, you will subtract 180. So supposing this is the formula we want to use, I'm just using it for example. So suppose this is the formula we want to use. I have OJ to be 120. What then will be the back bearing? Back bearing means that if I am giving OJ, I will not move from O to J, but rather I will move from J back to O. So I'm talking about JO. So JO is a direction, OJ is also a direction. But JO is a back bearing to OJ. So anytime I want to talk about back bearing, I must relate to an earlier forward direction. And in this question is the OJ. Do I add 180 or subtract 180? The rule says that if your given angle is less than 180, add. But if your given direction is more than 180, subtract. So my first question to all of us is 120 greater than 180 or less than 180?
Less than 180.
Less than 180.
It's less than
So
180.
it's less than.
Less.
Thank you. Rightly so. So if 120 is less than 180, the rule is saying that you will activate the plus side. The plus side of the formula. So what makes you take the positive or the negative is the value. When value is less than 180, you take the positive. When value is more than 180, you take the opposite. So what will be JO, which is the back bearing to OJ?
Sir, please repeat what you said right now. When it's more than 180.
Yes. We say,
So
when do we use a plus or minus in the formula?
oh, okay.
And I'm saying that you use the plus when your FB is a given information.
Yes, I know.
If the bearing of if that value, the bearing value is less than 180, you will add. But when it is more than 180, you will subtract.
Okay.
All right. So what do you think our calculation is going to be?
300 degrees.
So when you put the formula, this is how your JO will be coming here. So my BB, which I'm looking for, should be equal to my 120, which is given. Then because 120 is less than 180, then this side becomes plus. And what would that answer be? 300. Is that correct?
Yes.
Yes, Doc.
So if OJ is 120, then the back bearing to OJ is 300. But that 300 is defining JO. You are moving OJ. Your back will be JO. You are reversing the earlier direction. In the formula and in the computation, this is what we have to use. BB is equal to FB plus or minus 180. But I use the plus when the FB, the given information that I will substitute into the FB, is less than 180. Then I will add. But if the given is more than 180, then I will subtract. So let's check on trial 2. I have a line. I have a line with a definition or information as follows. The line is called KM. And the Km is equal to 330 degrees.
330 minus 180 is it?
330 minus 1.
80.
The line is forward bearing 330 degrees. What will be the back bearing?
150. 150 degrees.
All right. So using the same formula, we want back bearing today. So that should come out. But we'll take what we were given. That will go here. So we have it as 330. Then we have to decide, is it going to be plus or minus? You come back here. Since 330 is more than 180, you subtract.
Yes.
And when you subtract,
Nana kindly mute. Nana kindly mute.
so here the formula will say the 330, all right. But we have to this time subtract. And when you do that, you get 150. So what do you think that 150 will represent in terms of the direction? Would it be Km or to be MK?
MK.
Forward bearing.
MK.
It will be forward bearing MK,
Yes.
which is describing backward bearing of Km. You see how I've used the language? Forward bearing MK will be 150. But that say MK is a backward bearing 2 Km. So when you talk of the backward, you always have to link to a previously given direction for the statement to be complete and properly stated. But when you are using the direction on its own, it cannot be called back bearing directly. No. You can only call it by its forward direction. So like one of you said, Km is 330. MK is 150. That MK is a forward bearing when you are looking at only MK. But that same MK is a backward bearing if you are considering that you were earlier on K to M. So it always depends on the context in which the discussion or the question is being resolved. But this is the interpretation. Km is 330. If I want the back to Km, that would be 150. That's the back to Km. But that same 150 is talking about direction MK, which is correct. I cannot say backward direction or backward bearing MK. That is wrong. For M to K is the forward bearing. But MK is the back bearing if we have Km. Or if we had considered Km earlier, then MK is a backward bearing. Because the action is always saying find the opposite to the forward bearing. So we always have to respect that. So this is for the whole sector bearing. You add when your forward bearing is less than 180. You subtract 180 when your forward bearing is more than 180. How about if now we go to the reduced bearing and we finish our concept? When you are in the reduced bearing, what happens? That one is quite easy, very, very easy. You just have to be smart. So look at the sketch that I'm putting up again. We are going for quadrantal. Reduced bearing or quadrantal. reduced bearing or quadrantal bearing. Remember our cardinal direction. Here is what? Here is what? Here is what? And this one is. Now watch from here. Who is the opposite to north direction?
South.
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 Good. Perfect. Who is the opposite to west direction?
East.
East direction.
Good. These two key things is all that you need when you are in the reduced bearing rotation. First, I'll give an example, then I'll come and show you on the diagram how the effect is like. So suppose we have a line. You have a line, and the line's definition is PQ. And the bearing we are told is south. South, 20 degrees west. So the PQ is a forward bearing, and you want the back bearing to that PQ. Symbolically, it will mean from PQ, you are looking for QP. But how do you get the answer from your quadrantal notation? You only change your letters with the opposite. We said the opposite of south is what?
It's west.
North.
The north.
North. North.
No.
The opposite of west is what?
East.
East. East.
East.
So the south goes to the north and the west becomes east. When you finish, then you write a figure again. Why is it not shown? It's shown, no.
Yes, we can see.
It's showing.
So
It's showing. So check your network. And this will be QP. So QP is a backward direction to PQ. But what did I do? I maintained the angle and swapped the letters. Bearing in mind the cardinal, what I showed here. So because it started with the south, when I reverse, I'll go to the north. Because it ended with the west, when I reverse, I go to the east. Then I keep my 20 in between. So north 20 degrees east is a backward bearing to direction south 20 degrees west. Practically, this is how it is. If I consider the first line, I'm talking about something of this nature.
Hello, Doc.
Yes.
Doc, please, I don't understand. If you can go over small before you continue.
We are looking at the back bearing. We saw what happened with the whole circle and our formula. Now we are dealing with the reduced bearing or quadrant concept. But before I went on, I said, let us recall our cardinal direction effect first. And we said, when you are moving this way, you are going east. When you are moving this way, you are going south. When you are going this way, you are going north. And when you are going this way, you are going west. And I asked a simple question that when you are going south and you change your direction in opposite sense, where would you be heading? And we said north.
Move. Yes, please.
When you are moving south, west, sorry, and you change in opposite direction, where would you move?
East.
East. Thank you. So we were giving an example. PQ is south 20 degrees west, which is a quadrantal rotation. Do we all agree?
Yes, Doc.
Good. This one, we have not spoken about the quadrant where it belongs. First quadrant, second, we've not done that. We are just dealing with the letters and the values. So the letter we see is south. Another one we see is west. If you are looking for back bearing, then look to the opposite symbol for them. So now, according to the cardinal, who is the opposite to the south here?
Doc, north.
North, and that is what we wrote here. And then you go to the other side, the letter is west. Who is the opposite to west?
East.
East. So we wrote the east down here. Then we transfer the 20 back to slot.
Thank you. Thank you.
Except, Doc, please, what sign are there?
Come again.
There is some sign in between. The signs that are in between, is it plus and?
No, I was showing, you were not following. I was showing the change to arrive at your solution. So I'm saying that the S will transform to become the N. And then the west, W, will transform to become the east.
Sir, please, I did not like arrows.
No, they are not part of the solution at all.
Okay.
They are just illustrations. So I was saying that south was moving to become north. West was moving to become east.
All right.
Is it clear
Yes,
now?
Doc. Thank you so much.
Okay.
Thank you.
Now pictorially, this is how the effect is. South 20 degrees west is just one. It's in what quadrant?
Second quadrant.
So we didn't hear the question. Second
Second
quadrant.
quadrant.
We are
Second
still on this
quadrant.
one. We are just explaining further with the graphical representation. So PQ is in the second quadrant. It will be here, isn't it? But in terms of the drawing, this is what is happening with PQ. The arrow is pointing down. The arrow is here. This is the first instance of PQ. With P here and Q there. Are we clear with the sketch now?
Yes, Doc.
So where's the Q?
Ima, you have your hand up.
Yes, Doc. The distance, my worry here is that the value given was south 20 degrees west. So as you have drawn the thing in the second quadrant, I was expecting that it should, because of the west, it should go to the third quadrant.
Oh, Ima, you are right. You are right. You are right. How did we all miss it?
Should be in the third.
It should be in the third.
Say it should be in the
I
third.
was a bit.
Yeah.
Thank you very, very, very much. I appreciate that very much. That is good. That's why at times we want the thing to be interactive rather than just watching, and not partaking. So you are right, 100%. And I got it wrong. Let's change course and change things. Thank you, super. All right. So now we are here. Okay. Thanks so much. So this is the direction of the line. If you want to represent the letters fully, P will be here. Q will be there. Those who wanted to see how it impacts. Everything PQ. That's how the sketch will be. But watch something. I'm just demonstrating. Watch. I've not done sketch. I'm just demonstrating. If I'm moving from P to Q and you want the opposite action, I just have to change the arrow, right?
Yes.
All right. But when you change the arrow, you are now going to move this way. Let me bring you a color effect and see. I'm now going to move this way. Isn't it? You are
Yes.
reversing, isn't it? So then what happens to our line? Our line, yes, our line, the back bearing, fully implemented, is now going to come out this way. Fully implemented for the blue arrow. This one, these two arrows to work. They will appear here again. And this one will disappear. The same line will shift because we always need the start at the origin and then the end outside. So reversing the PQ will now become QP, but it will appear in the first quadrant. First one was PQ. You went down this way. When you reverse, you are talking about QP, and that will appear in the first quadrant. It's an extension because your start must be at the origin and your end must be pointing away from the origin. And you see that clearly when you draw the line and you're in the first quadrant, it will be north, 20 degrees east. But without sketch, then the easiest one is swap the letters of the cardinal. So what are you swapping south for? North. What are you swapping west for? East. You keep the angle in the middle. Yeah, finish. So quickly, let's look at that and then move on to other areas. I want to deal with the line A, AL. And it has a bearing south, (26 degrees) east. What do you think will be the back bearing to this? The back bearing will be LA. But what will be the bearing?
Say,
North 26 west.
North 26 degrees west.
West.
Pronounce again.
North
North
26 degrees west.
26 degrees west.
North 26
26 degrees west.
degrees west. Thank you very much. So we are done. So you got it right. And what it means is that this direction, which is the back to this, is the same as direction L A. But it is the back bearing direction to AL. Please, are we clear?
Yes, Doc.
Yes, sir.
All right.
So dog,
Yes.
dog, please, if you are drawing it on the cardinal point, it means the 20 will come close to the south.
Yes. The 20 will come close to the south.
To
So
come
here,
close to the
please,
south.
please. Because we said when you are in the south, but you know the letters is the quadrant. So when you are in south going to west, this is the angle you will clear. So the whole area here is 90 for the quadrant, and you have only 20. But you're moving from south towards west, and this is the south. So if it's south going towards the west, then your 20 will be close to the south. But if the value is more than 45 degrees, then you are heading closer to the west. But note that always the measurement is from the first letter. So the 20 will have to be measured from here. So that will be PQ. But when you reverse it, it will be QP, and QP will appear in the first quadrant. Please, is it clear?
Yes, sir.
Okay.
Dog, I don't hear you. I don't hear what you said. Please.
Yeah, network is what is helping you. I was saying that your network. Your network is fluctuating. That's why actually. So you see, you are not even hearing when I. The network at your end. The one who just was complaining. What is your center? Call her on the phone.
You can hear me.
If she wants the feedback from you, still with the internet, it won't work. So call her on the phone and then prompt her that that's the issue. All right.
Hello, Doc.
Yes.
Please, is it acceptable when you fix in an equal sign? For example, the AL is equal to south 26 degrees east. Is it acceptable, or we just have to write it
Oh,
this way?
yes, it is. No, it's acceptable.
Okay, sir.
It's
Thank you.
acceptable. Especially if the question was structured with the quadrantal notation. It's correct. So it means you are trying to write it like mathematics. That's okay. All right. So we look at coordinate system, we look at map projection slightly. The major activity we should have also considered was the construction of the linear scale. But because of time, we cannot touch on that. So that will have to be out of. Though generally, it is something we consider because the cartographer will deal with the map and in the end has to put a scale to it. We have dealt with skills, map skills, but then we are supposed to also learn how to construct the linear or graphic skills. But at times it's usually too short to handle that such things. And the best and the simplest time you need is 1 hour. That 1 hour is more effective when it is face to face. Because a lot of our construction skills are all there. All right, so we proceed. What I want us to look at generally, beside the construction of the linear scale, is a subject matter I raised earlier when I was doing the cartography. He said there were 4 elements of cartography. Who recalls that? The beginning, when I spoke of the definition of cartography, I said there were 4 elements. Or you want me to remind you? We said one of them was scale. Yes.
One of them was scale. And we have
The other
projection.
one
Is projection.
Legend.
And we have
no, the legend is not passed.
we have
The legend is
a
inside
generalization.
something. Good. The legend was inside something. There was map design. Do you remember?
Yes.
Map design to bracket
design.
generalization.
Yes.
Then there was map construction and production. There was scale, and then there was projection. All right, so permit me to share. Let me pull this one down. And then share material with you for further discussion. So we want to look at some general concepts about map design, and particularly the concept of generalization. The other time when I was speaking, I said a good map should have what? Here is different from the elements of cartography, which you have just read.
Should have a scale.
Good. A good map should have a title, a scale. Uh-huh.
A
Legend.
legend.
Okay.
Date.
Date.
Date. Who did the work? Probably. We call it bibliographic information. What again? The graphical information, longitude, latitude, or X, Y. 50 nothing.
Conventional signs. Symbols.
The conventional sign symbols are in the legend.
Conventional.
They are part of the legend etiquette. All right. So let me share this document with us, and then it's just a revision of some of the things we've done, and then we carry it on from there. All right. So, like I just said, a good map should have next to the map image. The map image is the typical space of the map. So we have the title, legend, projection, bibliographic information, orientation, scale. You can also have data about particular issues. I must say that the date, who did the map and all of that is part of the bibliographic information. The date, who did the map and all of that is part of the bibliographic information. All right. So these things should be around a map for it to serve a good purpose for usage. But then I want us to turn our attention to something we call generalization, which is considered and it's always part of the cartographer's work. It is considered under a broad element of cartography we call map design. Map design. So what is cartographic generalization? The definition is that it is the selection and simplified representation of details appropriate to scale and or the purpose of the map. Some will also tell you it is the reduction of the amount of detail in a map in a meaningful way. Both ways, as we have seen when we're dealing with the elements of cartography, we realize that because of scale, things can look small. And as things are looking small, generalization comes in to tell us whether by discretionary experience and years of service, a particular feature that is looking small and likely to disappear because of scale. But very, very important to still be shown. So generalization will tell us that yes, your scale is forcing the thing to look small. But as for this one, people must still see it that it exists, is there. So that is with the cartographic generalization. There are two forms of it. We have graphic generalization, which tends to affect the geometry of objects. The second one is called conceptual generalization, which tends to affect the attributes of the data. So having gone past the division, there are two types of generalization. Conceptual generalization, and then we have geometric generalization. So the kind of generalization we apply, we can trace it to either graphic generalization or conceptual. We look then at some models for our understanding. For now, a few of them have been listed here. We have classification, we have selection, we have symbolization, and then we have enhancement. For graphic generalization, we have selection, we have simplification, we have exaggeration or what we call enlargement, and then we have displacement. I want you to write these ones down. Selection. Simplification. Exaggeration or enlargement.
So what does that mean?
Displacement. Which one?
What does those signs mean? Those signs.
He said we should write them down.
They are expressing the generalization concept.
The signs.
But I don't want you to concentrate so much on this.
Lizzie, you're giving us.
You will check on other sources to get a clearer picture. But I just said that right selection, yes.
You said that these signs are what?
These are the expression of the generalization under graphic generalization. But the ones that I wanted you to concentrate on are selection, simplification, enlargement or what we call exaggeration, and then the last one is displacement.
So, sir, we should leave the merging out. Eh?
Yes, leave the merging out. I'm not saying that it's not part, but I'm just trying to select from.
Okay, sir.
Then we have conceptualization. That one to the selection or omission. There is ray classification. And you can also have ray symbolization. So I've just done an intro for both, but there's a reason why I want you to select or write down those that I've given to you. So we proceed and look at how we deal with maps and use maps. How we deal with maps and use maps. But I'll briefly go through that. We'll have our material and we should be able to read and understand. Most often, the maps that we use are either in hard copy or soft copy. Hard copies are those that are being referred to here as paper maps. The soft copy are the ones we open on the computer. They are not printed. You open it in the computer. They are all ways of using maps. But they come with the advantages and disadvantages. For instance, when you are dealing with paper maps, one of the advantages is that usually the printout is very good. You can get a very good graphic quality or high resolution printout. It is of high information density. Because you are printing out, you want to put as much information therein as possible. The third one is that depending on the computer you are using, you can have various formats of printout. You can have various formats of printout. You can print A3, A4, A0, all the other models that we know of. A0 extra, all of that they are there. You have the leverage because before you issue the command, you would have designed how you want it out and at what scale you are printing. So that's the advantage. No need of equipment. This is more often when you have printed out already. Then there's no need of equipment. This is not the same when it is in the soft. In the soft, you need a computer. You need a software that can open that map. But when you have printed already, you don't need any equipment again. What is the disadvantage? It is static because once you print out, that's the information. If any new thing happens in the field for which you have to go and gather information, your map will not show it. Your map will not reveal it. Again, any printed map or what we call the hard copy comes at a fixed scale. Comes at a fixed scale.
Kindly mute.
So the disadvantage of using paper maps is that they are static. Once you print, you are printed. Any new development cannot and will not be found in that map again. If you want it to be captured, you have to go and do the same map again to incorporate the new one. The scale tool is defined and printed with, so it comes with a fixed scale. You cannot zoom in, zoom out, and manipulate as it is possible with the soft copy concept. Physical boundaries to areas are portrayed. You need to show the edge where your map extends to. No adjustment can be made to individual demand. After printing, you are done. Nobody can come and tell it that there's a new road they want to include. So that is it. We go to the soft environment. They are usually what we call on-screen maps. On-screen maps. Because it is in the computer environment, you can zoom in, zoom out, you can interact, you can pan. All of these are possible with the on-screen. You can make adjustments, zoom in, zoom out, adjust, reposition symbols. You can even reposition symbols, lines. You can adjust their orientation a bit here and there. All of this is possible in the on-screen or the soft copy environment. But it is not possible when you have the paper maps or printouts. You can transfer the information from your machine to somebody's pen drive. That is not possible with the paper map, but it is possible with the on-screen maps. So I can tell you, oh, I have a map of UTC, so you are interested, I can copy onto a pen drive and give to you. That is what the second statement is talking about. It can be linked to additional info. 3, it allows for panning and zooming. I've said that one already. Then 4, it allows for possible dynamics and interaction. You can do what we call animation. You can do what we call pop-up. Something's on the map, you see, you click, and then something appears on your screen. It's a certain effect. That is not possible with a paper map or a hard copy of a map printer. What are the disadvantages? Usually, it offers low screen and color resolution because most screens that are high and powerfully resolved, they tend to draw a lot of energy. They waste a lot of energy. So most designs try to play down on the energy level by reducing the screen and color resolution. Output conditions may vary. Because the same map, I go to print, full extent, you go to print, you have zoomed in. So because of that, you can have outputs varying. How big your screen is will show how large you can do with your map. But of course, as you know it, your computer screen or monitor cannot be as large as, for instance, an A0 printout format. Nobody has a computer that has a screen as giant and big as an A0 paper. So in terms of display size, you are always constrained because you are watching through the screen. You are always constrained by the capacity and space of the screen. Unlike the paper maps or hard ones where they can be printed to as large as A0. Then the last one in terms of the disadvantage is that equipment is required. You will need a laptop. You will need a desktop with a software that can open that map. So you need to have that equipment, the map. Please, are there any questions? My last shot that I'm adding to this is about geographic modeling and the principle of visual variables. In cartography, usually we tend to map information through 3 avenues. Whatever that the cartographer shows on the map is mapping that information through 3 avenues. He will show information that depicts points. He may show information that depicts lines. He may show information that depicts area. So whatever we have in the map environment, we can trace the feature, that geographic feature, to whether it is represented by a point, symbol, like the positions of street lights along the road, like the position of a borehole in a community. It is a point feature representation. Others are line feature representation. Like, for instance, a river that passes through a community. It's a line we use to represent it. Then the last one is area. The line features, you can talk of people's pastor boundaries. You can talk about road network within a community. All such things cartographically will have to be represented by a line. So when we talk of geographic feature modeling, basically we are looking at how we represent the things we see around us naturally in the map environment. We make use of lines, points, and area concepts. So for each of them, the examples are there, and that is what geographic modeling is about. So what are the characteristics of point features? You find them in this, which will come to us as part of the material. When it is line feature, who are examples of that? Rivers, roads, pipeline. And this is usually the nature of the line feature. When it's an area feature like a forest, like a lake, like a pond, what are the characteristics? Buildings, pastures, they all are examples of features well represented by area concepts. Max, your hand is up.
So please, with the line features, can we include railway line?
Oh yes, you can include a railway line. You can include a railway line. It's just like the roads. You know, when your scale is large, roads can be shown with weight. But when the scale is small, usually we use a line to represent the road. You fear your hand is up.
What about thread
What?
for line? Thread.
Thread.
Yeah.
We are talking about geographic
The
feature.
line.
I'm talking about geographic feature.
Yeah.
We are thinking, we
I
trying to
thought
think.
we are giving examples in the line form.
Yes, but that example should fit a geographic feature.
Oh, okay.
Because the essence is that it is the cartographer who is thinking of all of these things around man and who wants to represent it. So what the geographic feature modeling concept is just saying is that any map we take and we begin to look at the features that have been represented in the map and relate to them in life, in real life situations. You see, the form of the feature is either talking to a point representation, like I gave, the electric poles. The electric poles, they have a point representation. If you have a borehole in a community, yes, it may have the curve or circular design. But in terms of position, most often we tell you where the borehole is. So we'll give you a point representation. Then others may have an area representation. Like if you have Lake Busumtree, they will give you an area representation. So all that the geographic feature modeling is saying is that when the cartographer was thinking of how to represent features around us, the best that he was able to come up with in representing feature was either a point, a line, or an area concept. And it runs through, or you look at the legends that we use for maps and other things. When the thing has an area concept, you will see that the legend also gives it an area symbolization. So if it's a pond, the legend wants us to know as pond or lakes, then they will put something that looks like a circular enclosure with a space trap in the middle. That's an area. But then you see rivers to be given some meandered lines. So that is what basically the geographic feature modeling is talking about.
Hello there.
Yes.
Hello there.
I'm listening, please.
Hello there. The geographic modeling.
Yes.
Include the use of spot height.
Come again.
Hello. I wanted to know if
Yes,
the geographic modeling has to do with the use of spot height to show the difference between the sea level and all that.
please. We have mixed about 2 or 3 concepts. Sea level is different from spot height. Yes, geographic modeling will tell you that spot heights are picked at locations, so they are point data. So, is it clear now?
Yes, please.
Good. So all that geographic feature modeling concept of cartography is saying is that the things we record of geographic features around us, thinking about representation, some of them can be represented by points. Some of them points will not work well. It's the line that will work better. Some of the line will also not work well. It is the area concept that will work well. Good. So these points that we are talking about, these lines that we are talking about, this area that we are talking about and their representation takes us to a very unique and interesting point. Let me jump all of this symbolization. How all of these point area issues can be represented. How do we deal with them? Some of the representation are letters, some of the representation are pictures and the like. But that is just for general set. What I want you to look at as the next major issue is what we call visual variables. We all understand that whatever the cartographer puts and eventually is calling a map will contain information about either point features, line features, or area features. That is how the representation will be. But then, in terms of the same symbology, we have seen that there are ways of making some symbols more pronounced in effect than others. And for instance, we tend to use certain colors more for certain representation than others. Most often, you see water bodies represented with blue, because our understanding of issue is that water looks close to a blue line than to a blue color rather than to a red color. So we do that. So the aspect and the final part of our discussion is looking at what are called visual variables. And visual variables are just ways in which the symbology of a map can be controlled. Visual variables touches on 7 key issues: position, size, shape, value, color, orientation, and texture. This model of placing emphasis or using these characteristics to lay emphasis was developed by Jacques Bertin. Jacques Bertin, a French cartographer. He came up with the concept of visual variables. If we are doing advanced cartography, there's a way we can let these visual variables communicate more effectively. It will tell you when there are times you are dealing with point features in the midst of others, which color to use to let it contrast with others for it to be seen well. So he gave us this 7 perspective of how we can communicate, or how we can impress, or how we can still make our difference compared to our surroundings. The 7 areas are position, size, shape, value, hue, which is the same as color, orientation, and texture. For each of these, he explains how they help us to support our map work. So it begins with the position and says that the position of a map element is important in cartography. Absolute location on a map cannot be altered. But the position of labels and information can affect the viewer's perception of a map. So we are agreeing per the position concept. Where is the thing located? These things are forming cluster, but there's a distance or space between this one and the next. It's still position, but arrangements here will suggest a kind of spread out or dispersed environment. Whereas by the same position, we could have brought all these 3 designs together. The other one is size. And here to the characteristics of size and its usefulness is at play here. Naturally, when I show things like this, in our mind, the bigger the size of the representation, the bigger we think the phenomenon is impacting. For instance, if I'm doing qualitative or quantitative mapping, or what we call statistical mapping in domains like map reading, interpretation, and other issues. When I am talking about a disease happening in an area, when I'm talking about population in an area, I can use dots, but the dots will come in sizes. And as soon as I say a size that is very big compared to a size that is small, I understand the impact of the phenomenon, whether it's population or it is disease. The big dot will mean that the effect there is very big. The small dot will mean that the effect there is very small. So basically, as we go through these 7 concepts, it highlights how we apply them in map. How we apply them in map. We spoke of map types. There are even categorizations of maps as quantitative and qualitative. And at times, this visual variable, or how we let things look like, has a way of influencing the information being gathered. So all that Jack is saying is that we are through geographic modeling, plotting point, line, and area concepts to represent features. Agreed. But he also came with a perspective that this same line, point, and area feature representation can be viewed or can be manipulated or can be controlled in a way using these 7 characteristics to bring about differences and uniqueness in our representation. So you get to an area, a map may have dots generally, but then visual variable can bring, for instance, color in to bring about differences. So some of the dots are red, some of the dots are blue, some of the dots are green. And then in the legend, those that are red, we are told what they stand for. Those that are blue, we are told what they stand for. It is part of the visual variable. Or we are looking at the whole country, Ghana. We are drawing a map of Ghana with the regions and the regional capital, but we are basing it on population. So the population, we want to see people to appreciate that one region has more population than the other. Then we use dots that have sizes. So as soon as I see that you have shown in your legend sizes for population, and I see a particular size belonging to small, then I know the population in that area is small. I go to another region, the size of the dot has increased, meaning the population there is higher. It is the works of visual variable that is bringing those differences supposed to help us to appreciate the work. So I'll leave that aspect when we get a material, we'll read it. But basically what I say is that having understood that we can represent geographic features at either line, point, or area, we can also bring in a twist through the visual variables to talk about various effects. Some of the effects may be in value. Some of the effects may be in color. Some of the effects may be in size. Some of the effects may be in position. They are all important for describing and appreciating the geographic space and how things play in this space. This brings us to the end of our work. And if there are no questions, we'll end it here. But we're saying generally issues that we have dealt with both in surveying and then in cartography. So if there are any questions, let me know. Other than that, our story for the day comes to an end. I'll be sending you the rest of the material so that we can go through. For our piece, because of the structure and how we dealt with issues, what we'll be looking at in the first part of our piece for cartography, all the issues that we've touched on so far are represented or can appear in our quiz. Typically, coordinate system, typically map projection. And then the concept of generalization, visual variables. I need to, however, say that a lot of the work from the surveying aspect will be based on week 1 and week 2. That is for the quiz. As for the end of semester, all the issues cut across. But for the quiz, we are looking at week 1 and week 2. And we will have a sense of who is week 1 and week 2 from the notes and material that will be given. Issues on the assignment. Issues on the assignment that I spoke of will not be part of quiz 1. Every assignment that I gave to you will not be part of quiz 1, but can be part of quiz 2 and then the end of semester. Are there any questions? In the meantime, as I said, because of the way we are shaping ours, this is where at times when you come for lectures, it helps you. Or when you join, it helps you. I've stated that surveying, we are looking at week 1 and 2 of the surveying. We have seen our material that has been laid. If there were any assignment therein that you have not done yet, the assignment is not impacting on quiz 1, but may impact on quiz 2 and the end of semester. So note that. But everything that we touch briefly on under cartography is also certainly part of our quiz. Particularly the areas of body system map projection. And then the elements of cartography, the scale map projection, the design, and all the like. So that is with that. So with the material, we have an idea what week 1 and week 2 is entailing, which we need for the quiz. All right. So, as no questions have showed up, and at least we've seen the areas to concentrate for our quiz, then I believe the structure of issue and the strategies for learning and all of that, we are beginning right away to go through them. All right. We spoke of, you were seeking and asking me to give some past questions. We will find one. But then, because I was also speaking of the scope and areas to look at, when you are answering or you are going through your past questions, you have to be careful. Because some of the past questions may touch on areas that we have not aligned for ourselves, at least per the discussion I'm having with you. So when those past questions come in, be careful not to be stretching your learning and be under stress because it is a past question, but also being mindful of what we have discussed for quiz 1, especially for the end of semester and quiz 2. Please, are there any questions?
Hello, sir.
Yes.
Sir, please, the last time we met, you said you would give us an assignment on bearing. Getting to the end of the lesson, but you didn't give us.
Oh, okay. Thank you. So I'll I will drop that in addition to the material so that you try it. Thank you for it. Any other?
Please, since next week will be our first quiz, I am just praying that you give us the materials. You promised to give us the slides, so I'm just asking if we can get that in addition to our notes so that we can prepare for the quiz.
Oh, in addition to your notes, okay. I hear you. And I hope you have done your notes, but that is your master, not my material. All right. So thank you all very much. In fact, for the last one who asked the question, your material, we are having a discussion. Some have pushed. If you were with that at the beginning, some I explained before we started. So you rest assured there's something coming in. But your golden egg is still your presence and the notes that you did. And for me, I've told you it's a technical subject. So when you are learning and reading, make sure key elements of definitions and other explanations, you don't lose track of them. All right, then. So thank you all very much. Thank you more especially for staying on, dragging through the night for a nearly 3-hour engagement. Right, it's for the well and good. And I believe with the way we are strategizing issues together, should get it right. As for the first quiz, typically it's going to be an MCQ, 20 questions, possible answers are there. But if you are not in the habit of reading well and noting details, you can run into trouble. So that is with that. So God help us all, both in our study, in our issues. But we can always at any time draw our attention if there are certain things that are still a challenge. We seek some clarification here and there. We can look at how we find time and space to do those things. That's right. All right. So thank you all very much once again.
Thank you too so much for your time with us. And we are so much grateful for your commitment throughout this time and your dedication to make things clear to us. We are also much grateful, and we hope that all interests will be served. We will also excel.
Aha. Okay, you finish your point. There was something that I needed to check.
Okay, so I'm near finishing. We will also excel to make sure that the work you have done reflects so well. Thank you once again very much.
Thank you. How I said what I remembered at the beginning when I gave the introductory lecture and I was reflecting on past performance and other things. There were some questions on or concerns on how we could have gotten some past questions here and there and the likes. And the fact that when we go to do the exam, you don't get to see what we worked on. So I followed it up with the e-learning platform managers, and there was a certain discussion that was going on. And The difficulty is how to resolve that. One, they informed me that letting you see your question, especially after the exam or downloading it or whatever after the exam, it's possible to set up. The challenge, however, is that as it has been for the past number of years since they started the program, a lot of our members tend not to be able to honor the quiz when it's being done. As to whether it's a network challenge or whatever, they tend not to be able to honor the quiz and only show up a bit late or later. So their challenge is when they release or they give you the access for you to download. And some of our members, as it has been the case, failed to show up or couldn't do the exam at the time you were doing the quiz. But they have to also get the exams done. Then it becomes a challenge between the e-learning platform and getting back to the lecturer involved to say that a section of the people couldn't write your first quiz, so set another MCQ for them to come and write. Because the disadvantage is once they release it to you, that same question cannot be given to those who come late and make various complaints or excuse for why they are late. This is one of the reasons why they don't usually do that. But they said if by concession other things we agree can be done. But then the risk then is once it is also released and we get our download, whatever reason that may have caused a member not to have come to write, it means that member loses everything. Because in the wake of issues, it will mean another consultation with the lecturer, it will mean another set of questions has to be developed so that they will also come and write. And it can be cumbersome and stressful. So it is one of the reasons why they don't usually give you a question or let you know your performance. So and I said, okay, fine. Then maybe we need to talk to my members too and see. But then that's their challenge. Some of you at times don't come to write a thing when you're supposed to write, and they come with various reasons. So they end up writing later after majority of the group are probably written and done with.
Oh, okay. Thank you for the follow-up. In all, I think there's a way they can still go by it, but we are just left with four papers to be out of the system. Perhaps if they can do anything to it, will be for the benefit of the third cohort and the subsequent cohorts that may come. But well, as for we, whatever goes, we are near the finishing line. So however we were able to survive till now, I'm sure we'll still survive to the finishing line. Thank you for your follow-up.
You're welcome.
Hello, sir.
Yes.
Sir, I chanced on one of the past questions, and what I observed was the sub questions were so many. So, sir, we are pleading that you reduce it a little, because when one question comes with so many sub questions, you become confused. In fact, so please, I'm pleading on our behalf that on the class behalf that you reduce the sub questions a little for us.
Which one do you call sub question? And which one do you call many?
For instance,
Sir.
maybe question 1, you'll be given A, B, C, D, F, and others. So,
Is your name Curtis or just a name on your phone?
It doesn't come from one area. You pick the question from different areas. When such questions come, it becomes very difficult for students to get all the questions under one area right.
I don't know what you mean. What you mean
I don't
by
know if I've made myself clear.
It doesn't come from one area because one, my questions, I don't have A, B, C, D, E, F, as you are saying. There's nothing like that. There's nothing like that. It's either an A and a B, or at most an A, B, and C. Then it is true, we don't focus on one area to set a question for one area. That one I can tell you, it's a fact. I don't do that. What I do is I do a spread over. I do a spread over, and then I expect you to read through the questions, and then in your choice, optimize your capacity and understanding of the issues that you want to respond to. So I don't set a question 1 and everything, for instance, is on map projection, or everything, for instance, is on classification or surveying. No, I don't do that. So there is A, B, C, because the thing is about 20 marks. And we are not, what we have come to do, or what we come to respond to in exam, it's not, I don't want to use the word, it's not a 10 paper where you are writing a full essay. It's in short bits. You respond to a particular concept or ideology, and then you write about it in a summary understanding of issues. Then we move on. But like I say, yes, it is not focused on one area. It cuts across. So the idea is for you to read through carefully, and then pick questions that you believe, though they are spread out, you have an understanding of the issues to respond well to the question. So that is usually the design I do. But I don't have steps all the way to this end. Of course, for instance, I just spoke to you about visual variables. Now, if a question is being set on visual variables, I have an option to select from 7 possibilities. Because the concept, when I was being, was being explained, I have 7 entities. You have size, you have position, you have hue, you have texture, all those things are there. And I've not even done a question where on visual variable, for instance, I go for all the 7. But probably I may select from. So you will have to read all the 7, and then when you come, what is being suggested is what you respond to. So I don't have an A, B, C, D, E, F, as you may say. If the concept has a leverage, a number of issues, then at times I may select from there and ask you to speak to those issues.
Hello, sir.
Yes.
Please, I'm sure we will get the recording in addition to the slides that you send, if code recorded, so that we can make up our notes too.
I want to believe so. But the other time, one of your people told us when you go to YouTube, is there. He showed you how you can access it.
Yes, please.
I want to believe that it will still follow that cue. All right. Any other, or we sign off?
Almost 10 o'clock.
All right. So thank you all very much. And then all the best as we look at the issues and follow up with the issues. Have a good night and a good rest. For surely tomorrow is another day. Thank you all once again.
Thank you all once again.
Good night.
Good night. Thank you. Sir, will we meet again? Can we meet again? Or you are done?
Oh, for me, I am done. Except if we are suggesting such. As for me, it's about probably the reps. It's probably about you and your members and all of those issues.
Oh, okay. Let's talk. So if you are having any problem, you can call
No problem. Yeah.
Okay.
All right.
Okay, thank you. Good
You're
night.
welcome. Good night.
Bye.
Bye-bye.
Thank you. Bye.
Case closed. Let's go and sleep.
Huh?
Let's go.
Is that what?
I said case closed. Let's go and sleep.
Case closing. All right.
We close
We hear you. You are done with.
we closed docket on everything. I said we
Really?
have closed docket on everything, so nothing more.
If anything, we'll call you. Are you ready?
Call me la.
Are you ready?
You just give. I am just.
You are here.
Emmanuel.
Yes,
Emmanuel,
dear. Yes.
please, for the quiz one, the point is stated before the map projection. I didn't get the first topic you
Coordinate
mentioned.
system. Coordinate system.
What system?
Coordinate. Coordinate. Coordinate.
Oh, okay. Oh, okay. Okay. Thank you.
But you watch on. I'll put everything on our platform. So.
All right. Thank you.